Welcome to Let's Talk Micro. Hello everyone. Welcome to another episode of Let's Talk Micro. I hope you had a great week. Let's Talk Micro is available on Apple Podcasts, Spotify, Google Podcasts, Stitcher, TuneIn Radio, Overcast, Audible, Amazon Music, Pandora. Wherever you listen to your podcast, you can find Let's Talk Micro. I am also on Instagram as Let's Talk Micro, no apostrophe, and on Twitter as Let's Talk Micro 1. So go ahead and follow, please. I hope that you listened to our last episode, which was an interview with Karla Zamora. So for those of you listening for the first time, on the last episode, I interviewed Karla. She's an environmental microbiologist from Querétaro, Mexico. It was an amazing episode. So before you listen to this one, actually go back if you have time and listen to that episode. It is called A Conversation with Karla Zamora. It was our first interview. Let's Talk Micro's first interview. I think it went really well. And I said it on Instagram. If you're a microbiologist and you want to share your story, please go ahead and contact me. You can DM me through Instagram and I will look at your information. One of the goals of Let's Talk Micro is to see what microbiologists around the world do, like what their procedures are, what organisms are prevalent. How do they get that ID, that susceptibility? There are various methods out there, some a little bit older than others. So I want to see what the process is. What kind of education do you need in different parts of the world to do this job? If you're not a clinical microbiologist like Karla, she's an environmental microbiologist, I want to hear what you do. So if you're interested, just send me a message through Instagram and I'll look at your information. So in the interview, she talked about what she does. All of us as consumers, what we know is the news, what we hear in the news, like there's E. coli on hamburgers, there's E. coli on lettuce, they recalled the product. So how do they find out? So this is what she does. Very important work. So she checks products from companies like food items to rule out the presence of bacteria. As consumers, we do not want those products out if they have pathogens, right? So these products, they can be harmful to our health, and we don't want outbreaks. So it definitely, like I keep repeating, is very important work. We want to make sure that when we get that product, it's safe for us to consume. And this is what she does. So, like I keep saying, if you have time, go back, listen to the interview. Great information. So in the interview, Karla mentions various types of agar, of media. And that's what this episode is about today. Some of the ones that she mentioned, we clinical microbiologists might not be familiar with, and then others we are. So she talked about Palcam, Oxford, which are for listeria, and those on the clinical side. At least here in the US, in the labs that I work with, I was not exposed to it. And then she talked about Hektoen, XLD, and EMB, which those either through school, and Hektoen XLD definitely still used in clinical labs here. So those we clinical microbiologists are familiar with. So I'm gonna start with Palcam and then go on to Oxford. So Palcam, and I'm getting this information from Becton Dickinson. They're manufacturers of media, and they manufacture Palcam. So this agar was developed for the isolation of Listeria monocytogenes from food items. So how do you achieve this isolation? In previous episodes about media, we talked about enriched, selective, differential. So we know that, for example, McConkey, it's selective for gram-negative rods and is differential for lactose fermentation, right? So it has lactose, obviously, and then it has crystal violet, which inhibits the growth of gram-positive organisms. So how do we achieve selection with Palcam? Okay, well, this agar has lithium chloride, polymyxin B sulfate, agriflavin HCl, and ceftazidime. So what is the differential for? Well, the differential portion is for esculin hydrolysis, which actually all the Listeria species they do. And this is seen as a brown-black color in the agar. Sometimes staph and enterococcus can grow, and for this the agar has mannitol, which is for the strains that actually fermented. And mannitol fermentation is seen it's a color change from red to yellow. So what do the colonies in the agar look like for Listeria? Well, they look as gray-green colonies surrounded by dark brown to black halos. Once you plate it, you can incubate it from 18 to 24 hours at 35 to 37 degrees Celsius. And if it's negative, you can re-incubate it for another 24 hours. So this is a new agar, maybe new for you clinical microbiologists out there, but it's for Listeria. And then it has antibiotics and different, certain components that help for the isolation. And then the differential portion is for esculin hydrolysis. Whereas on the McConkey, the one that definitely everyone's familiar with, the differential portion is for lactose fermentation. So there you have it. We have Palcam, and which I said for Listeria monocytogenes, but also from other Listeria species. For those of you, your clinical microbiologists out there, you definitely should recognize, polymyxin B and ceftazidime antibiotics. Ceftazidime is a third generation cephalosporin, which is affected, when the organism it's an ESBL. What's an ESBL, students? Extended spectrum beta-lactamase. So then we move on to Oxford, and this agar is also intended for the selection of Listeria monocytogenes from food items. So this information is from Fisher Scientific, another manufacturer of agar, and both BD and Fisher, they have no relationship to this podcast. They're not sponsoring me or anything. So I'm just getting their information. They're widely known in the microbiology community. They supply a lot of the agar. So I'm just using that information. So Oxford has lithium chloride, fosfomycin, colistin, cycloheximide to inhibit the growth of most gram-negative and gram-positive bacteria. And now, once again, you microbiologists out there, definitely in the lab, in the clinical side, we definitely hear a lot about colistin. We use it when we have organisms that are MDRO, multi-drug resistant organisms, as a reflex antibiotic. And then fosfomycin, the same. Fosfomycin, we use it when we have ESBL. Fosfomycin was intended for E. coli and Enterococcus faecalis from urine specimens. So when we have an E. coli from an urine culture that's ESBL positive, we use fosfomycin. So you should be familiar with this. Just like Palcam, the agar has esculin, which is hydrolyzed by Listeria. And what do the colonies look like? They are black with a black halo and a sunken center. So there you have it, audience. Two types of agar that are for Listeria, and they're almost selective for it, and then they are differential for esculin hydrolysis, which Listeria does. And we keep talking about Listeria. This is definitely a very serious organism that we want to make sure that it's not in our products. It likes the cold, gram-positive rod. It's implicated in a variety of infections, central nervous system, bacteremia. It can be passed from the mother to the child, when the mother is giving birth. So it's a very serious organism. So we definitely want to make sure that our food doesn't have it. Likes it can survive in meat, cheese, and like I said, it likes the cold. So it's definitely a very serious organism. So learning about, for me, since I was not exposed to this agar. Learning about it, it was definitely very interesting. So now that we talked about gram-positive rods, we move on to agar for gram-negative rods. So Karla talked about EMB, which is eosin methylene blue. So this agar is for the isolation and differentiation of enteric bacteria, enteric or intestinal. It has eosin and methylene blue, which mostly inhibit gram-positive bacteria. And it has lactose, so it is differential for lactose fermentation. And those of us, either you see it on the workspace or we learn it at school. Like I mentioned it in the interview. So before I was a medical lab scientist, I was a medical lab technician, and I got that through the military. And when I was going through that program, I definitely learned a lot more about EMB agar. After I graduated and I started working in the lab, I didn't see it. And I finished the MLS program. And in the labs that I've been on, I haven't seen it either. But I know it is used in other parts of the world. I don't know how much in the US, but I've seen posts from all over, from Instagram, from fellow microbiologists, posting pictures about it. So it's still widely used. So it gives E. coli has a classic presentation on it, a classic morphology. It's a green metallic sheen. So other lactose fermenters, they produce blue-black colonies. So that is another agar that it is differential for lactose fermentation. So keep that in mind. And then Karla also talked about Hektoen and XLD, Hektoen enteric agar, and XLD, which is xylose lysine deoxycholate. These two types of agar, they are selective for gram-negative rods, and they are differential for lactose fermentation and H2S, or hydrogen sulfide, production. So what do these colonies look like? Well, if the colonies are lactose fermenting, they look yellow. And this is because the agar has pH indicators that change the color to yellow when acid is produced. And then H2S producing colonies, they turn black. So like Karla said, we use this agar to aid in the differentiation of salmonella. And definitely XLD and Hektoen, they're very popular on the clinical microbiology side. Those labs that used to, nowadays, the stool cultures have moved on to molecular. But you still, depending on the policy of the lab, if you have, let's say you do a PCR and it's positive for salmonella, you go ahead and plate that sample, isolate your salmonella, and then send that sample to the state. Like the same with Shigella. Some places might just send the container with the stool, it already has a preservative, which is called Carry-Blair, and send the stool directly to the state. But some labs try to isolate the organism. You might also work in a lab where you actually do the stool culture. So Hektoen and XLD, they're used as part of your stool culture. You can typically can do a blood plate, a McConkey, Hektoen, an XLD. You can do a McConkey with sorbitol for E. coli 0157. And as I have talked about, in our stool we have a lot of bacteria. We have a lot of enteric flora, a lot of bacteria in our intestines. And that's good. They're not harmful, they're just there. So, but a lot of these, they're lactose fermenting. So the stool pathogens like Salmonella, Shigella, they are non-fermenters. So they do not ferment lactose. So this is typically what you're looking for when you're in the bench. You look at your McConkey plate, you're looking at your Hektoen, you're looking at your XLD. So you're looking for non-fermenting colonies. In the case of Salmonella, it's an H2S producing organism. So you're looking for those black colonies. So you correlate, you see non-fermenter on MAC, a non-fermenter on Hektoen or XLD, You isolate that organism to a blood plate or just to perform a proper ID to rule out Shigella. If you see a non-fermenter MAC H2S producing an XLD and Hektoen, the same thing, you isolate that organism to do an ID, to do a typing, and we'll talk more about that on another episode. But that's what we do on the bench. So that's why this plates with the lactose fermentation is very important, because these pathogens are non-fermenters. I mean, not all of them, but especially Salmonella and Shigella. If you have black colonies on an H2S, if you have black colonies on your Hektoen or XLD, you also have to keep in mind that you need to do an ID, because there are other organisms that can produce hydrogen sulfide. And like I like to tell my students, and I heard this years ago, there's an acronym called SPACE, which was S for Salmonella, P for Proteus, A for Arizona, which is now a subspecies of Salmonella, C for Citrobacter, and E for Edwardsiella. So keep that in mind. So I'm talking more about the clinical side for this, because on the environmental side, they have their different protocols. But if you're in the clinical side and you see an H2S producing organism, you have to go ahead and perform an ID on it to make sure that it's a Salmonella versus a Proteus, a Citrobacter, which are the two most common ones seen. And these are enteric flora. So just because it's H2S on the clinical side doesn't mean that you're going to go ahead and call it Salmonella right away, because there are other organisms that are H2S producers. So you have to always correlate that with performing an ID, isolating it so you can perform the ID. I mean, a lot of times, depending on the amount, you can have enough where you can actually perform an ID on your Vitek. That's acceptable. But since sometimes, we have so much flora on the stool, you might have like 1 or 2 colonies of H2S mixed with everything else. So you're going to have to isolate it and then go ahead and do further testing to make sure that you actually have a Salmonella. But these are definitely 2 important types of agar that we use in the clinical lab, and they definitely help with Salmonella. So I've covered 2 more agars that are differential for lactose fermentation. So now we have McConkey that I mentioned in an earlier episode, and Hektoen and XLD. And I'm going to talk about Salmonella for a little bit. But before I do that, I always like to reinforce the order of streaking. When you're in the clinical side, when you're working with your plates and you're setting various plates, make sure that you follow the order of streaking. You always streak from least selective to most selective. You don't want to bring any of that selective material to your non-selective plate. So if you have a blood, chocolate, McConkey, you streak blood first, then chocolate, and then you move on to McConkey. And I find myself repeating this many times, but still, you see a lot of texts that they don't follow this procedure. And it can affect your plates. Sometimes, you see a lot of growth on a selective agar, and then on your enriched agar, like your nutritive, like your blood, you don't see as much. So you probably started the wrong way. You always want to get the accurate picture. So you start from your least selective, and then you move on to your most selective. So in this scenario, if I have blood, chocolate, McConkey, PEA, MAC, Hektoen, and XLD, what will be the order of streaking? Right, so you will go to blood, chocolate, PEA, MAC, and then Hektoen and XLD, or XLD and Hektoen. At that point in time, they're all selected for gram-negative rods. So there's a degree of variability where there's not a specific order. So you can do MAC, XLD, Hektoen, or MAC, Hektoen, XLD, or MAC with sorbitol, Hektoen, and XLD. But what you don't want to do is just strict, let's say, your McConkey or your Hektoen before your blood plate or your chocolate. So all of you techs out there and students, keep that in mind. The order of streaking from least selective to most selective. So just like Listeria, it's a serious organism that we do not want in our food. So is Salmonella. So what is Salmonella? Salmonella is a gram-negative rod. It is widely disseminated in nature and associated with various animals. Most common one, the chickens. It's normal flora in chicken. So it is transmitted from person to person via the fecal-oral route by ingestion of food or water contaminated with feces, and also ingestion of contaminated food products, such as poultry or dairy. As far as virulence, it has several factors that help protect the organism from stomach acids and also promote attachment and phagocytosis by intestinal mucosal cells. So as far as spectrum of disease, gastroenteritis, diarrhea, bacteremia, enteric fever. So this is a serious organism. And it is flora on chickens and other animals. So that's why they always say, make sure that when you have the cookie batter that it has raw egg, don't eat it. Make sure you cook your chicken to the proper temperature. When you're handling chicken, make sure you wash your hands. Make sure you disinfect the surfaces where you're handling that chicken. Make sure you bleach the area and clean it so you don't transmit salmonella. So this is definitely, so you don't get it and transmit it. So it's definitely found in food. So if you go to a picnic, like I said, your listeria can be in meat and cheese. You can have salmonella. You have salmonella in undercooked poultry. So you can get sick. So we want to make sure that also manufacturers of different products, they're different, those products are clean, like your lettuce, your vegetables, because it depends that you have a clean water system to irrigate your produce. Because if you don't have a clean water system, then make sure that it doesn't have any human waste on it. And that's why sometimes, you hear of outbreaks of bacteria like in lettuce and other vegetables. So we have to make sure that also the companies have to make sure that their product is clean. And this is where Karla comes in with her work. So it's very important. It's a very important work. And we as consumers, not only, the companies are responsible for making sure they have a clean product, but we as consumers also, we have to make sure that we properly handle those products. Cook your chicken to the proper temperature. Wash your hands. Make sure that your surfaces are disinfected so you don't contaminate. You don't get sick with it or get your family members or friends sick. So 2 serious organisms that we want to make sure that they are not in our food. So after this episode, if you haven't listened to Karla's, go ahead and tune in. Great information. And if you want to share your story, go ahead and send me a DM through Instagram and I'll take a look at it. And that, my dear audience, is the end of this episode. I hope you enjoy listening about these types of agar. I certainly enjoy talking about them. Continue that passion in what you do. Continue bringing that motivation. Continue working those organisms so we get those results out there and our patients can be treated. And what you learn from this episode, continue properly handling your food products. And companies out there, you're also responsible to make sure that you release a safe product. With chicken, you cannot, you're gonna sell it raw and people will cook it. So we as consumers have to make sure that we properly handle it and properly cook it. And so continue that motivation, be safe, and continue talking micro I'll see you next time and hope you have a great week. Goodbye.